Now we're going to work backwards and look at determining sample sizes based on desired confidence intervals. So what do we do when the margin of error is too big to be useful? Well, one way to make the margin of error smaller is to reduce your level of confidence, but sometimes that's not acceptable. You can't go to a lower level of confidence. Now, really, what you should do is think about your margin of error even before you take your first sample when you design your study. So to get a narrower interval without giving up confidence, you need to have less variability, and you can do this with a larger sample. So basically what we did here is we took the margin of error equation and solved for n. Now I personally am just going to go solve for it every time. This formula is not on your math chart, but you can see the relationship here that the number of samples required is proportional to this critical value, which is related to the confidence level we want, and the product of p hat q hat. And if we make this margin of error smaller, we need to make the sample size bigger. So let's go ahead and take an look at an example. An experiment finds that 27% of 53 subjects report improvement after using a new medicine. So this is the same example we were doing before. And the question is, what sample size would we need in a follow-up study if we want a margin of error of 5% with 98% confidence? So first of all, here are our numbers. We know that the p hat is 0.27 for our sample, and n is what we're looking for. If we want 98% confidence, actually it's not really inverse norm, my bad. You really need to go ahead and take a look at, there's a way to calculate it. Usually we're going to have it memorized, but I'm going to tell you right now, what we want z to be is 2.326 if we want 98% confidence. Basically what you would do is you'd look at your normal distribution and you would figure out 98%. Well, that would be in here, which means I'd have 1% here. So basically I would do inverse norm of 0.99 instead of 0.98. So change that right there. Okay, so continuing on, our margin of error is going to be the critical value, which is the 2.326, times the standard error for p. All right, so I can solve this for the standard error to figure out what my desired standard error is. Okay, so it's 0.00215. Well, I can plug this back into the formula for standard error, and notice how I put it on the left. So it comes up here, and I substitute in, and I have the p and the q's, because I know p hat, because they told me 27%, and q is just 1 minus p. Then I can square both sides, and I get this equation. If I cross multiply and divide by 0.0215 squared, I need roughly 426.39 parts of my sample. The only thing is you really don't want a decimal. Always round this up, okay, because this was resulting of a rounding down. So you always round your count up by 1. So we would say we need to run an experiment with at least 427 people in receiving the new medication in order to have a margin of error plus or minus 5% with 98% confidence. Now, this is great because we kind of had a rough idea of p hat already. But how do we know n before taking the first sample? So we don't even know what p hat is. So before gathering our sample, it's not too hard to determine how big a window we're okay with, what margin of error we want. And it's okay to figure out what the desired confidence level is. The question is, what about p hat and q hat? Now, if I know p hat, then I know q hat. That's okay. So since the number of samples is directly proportional to this product, and I'm trying to have some comfort here, I want to guess the biggest value for this so that I'm not too small on my calculation for this. So I created a table here of different p hats and q hats and their products. And you'll notice that when they're both 0.5, that's the maximum value for the product. So if I just assume, in a worst case scenario, what I'll say is that p hat is 0.05. So this is when I don't know anything about the population beforehand. So, for example, I want a sample size for 3% margin of error. All right. How big should a sample be if we want that? Well, first of all, assume p hat is 0.5 since this maximizes the product of p hat and q hat. All right. We're going to use a 95% confidence level, and then we'll go ahead and substitute in, find our margin of error, and we'll find our standard error. So 0.03 here, because we want 3% margin of error, if that's up here, and that's down there, right here. And we know we want the 1.96 for the confidence level. Okay, so I can solve this for standard error, and I get 0.0153. Okay, now I'm going to go ahead and substitute back into the regular formula for standard error. And I'm using the 0.5 here for the worst case scenario, and then the 0.53, squaring both sides, and then solving for n, I get 1067.97. Or basically, we'll do what polling organizations usually do. If they want 95% confidence, choosing the most cautious proportion, 50%, a sample size of at least 1,068 voters is required.